we will convert this analog signal into the digital one. How? We'll do sampling like at here after equal interval of time. So first of all, at this point, the signal amplitude is from here to here, and we assume the same level till the next sampling point occurs. Now what happens then? The signal amplitude shifted from this point to this point. Now then the same amplitude remains till the next. तो यहाँ पे जो पॉइंट है ना, जितना एम्पलीट्यूड एनालॉग सिग्नल दिखा रहा है तो वही एम्पलीट्यूड डिजिटल सिग्नल का रहेगा, और वो कांस्टेंट रहेगा जब तक कि आगे नेक्स्ट वाला सैम्पलिंग पॉइंट नहीं आ जाता. नेक्स्ट सैम्पलिंग पॉइंट हमें ये बता रहा है कि तब एम्पलीट्यूड एनालॉग सिग्नल का कम है, तो हम क्या करते हैं, डिजिटल सिग्नल का हम लेवल डाउन कर देते हैं उस पॉइंट तक. मतलब हम यहाँ पे आ गए. अब हम अपना डिजिटल सिग्नल का वही लेवल रखेंगे जब तक नेक्स्ट वाला सैम्पलिंग पॉइंट नहीं आएगा. अब यहाँ रहे नेक्स्ट सैम्पलिंग पॉइंट, तो फिर हम उसको लेके चलेंगे आगे तक. आगे सैम्पलिंग पॉइंट यहाँ आ रहा है तो हम डिजिटल सिग्नल का थोड़ा एम्पलीट्यूड बढ़ा देंगे. तो इस तरह से हमें डिजिटल सिग्नल मिल जाता है एनालॉग सिग्नल से. ओके, तो इन दिस डायग्राम it is shown that we are having ADC, analog to digital converter. We are giving analog signal and it is giving us the digital signal. इस डायग्राम में दिखाया गया है कि हम ऐसा एनालॉग सिग्नल दे रहे हैं इसे, और ये हमें डिजिटल सिग्नल आउटपुट की फॉर्म में दे रहा है. ओके, in case of ADC, let me take an example of 4-bit output. They were having ADC which gives us 4-bit output digital signal. Now what is the resolution? Resolution means 2 raised to power 4, because we are having 4-bit output, that is 16. That means at the output we are having different 16 patterns. That's the meaning of the resolution. And again, the resolution defined as, if we assume that our input maximum voltage is 30 volt, and maximum input voltage 30 volt, then resolution is again defined as 30 upon 2 raised to power 4 minus 1, that is 2 volt. So this is again the definition of resolution. Okay, now what it means? That the resolution is 2 volt. Okay, it will be clear with the help of our graph. Okay. रेजोल्यूशन क्या होती है कि हम जो एडीसी ले रहे हैं उसमें जो एडीसी हमें डिजिटल सिग्नल देगा वो 4 बिट्स का बना होगा. तो रेजोल्यूशन को 2 तरीके से बयान किया जा सकता है. एक तो 2 raised to power 4 में 16 मतलब अलग अलग बिट पैटर्न्स लाइक 0 0 0 0, नंबर 1, नंबर 2 0 0 0 1, ऐसे 16 लेवल बन सकते हैं. और दूसरा तरीका इसको डिफाइन करने का है कि हमें ये देखना पड़ेगा कि इनपुट जो एनालॉग सिग्नल है उसमें मैक्सिमम वोल्टेज कहाँ तक जाती है। सपोज वो 30 वोल्ट तक जा रही है, और इस पर्टिकुलर केस में रेजोल्यूशन हो जाएगी 30/2⁴ -1 मीन 2 वोल्ट। अब इसका मतलब क्या होगा कि ये रेजोल्यूशन 2 वोल्ट है, ये हमें देखना है। Now it is shown here that the bit pattern will not change up to 2 volt. So when the voltage exceeds 2, the bit pattern level changes. Okay. यहाँ ये दिखा रहे हैं हम कि जब 2 वोल्ट तक रहेगा ना, तो बिट पैटर्न की एक ही वैल्यू रहेगी, जैसे ये। जब 2 से आगे जाएगा तो नेक्स्ट पैटर्न आ जाएगा, ये वाला। हर 2 वोल्ट के इन बिटवीन है, तो लेवल नहीं चेंज होता है। 2 से आगे जाना चाहिए, तभी ये आउटपुट में बिट का लेवल चेंज होगा, बिट पैटर्न्स का लेवल चेंज होगा। इसीलिए कहते हैं कि रेजोल्यूशन 2 वोल्ट है। मीन ये लिमिटेशन है, जो इसकी लिमिटेशन है 2 वोल्ट की, वही इसकी रेजोल्यूशन है। क्योंकि 2 वोल्ट तक तो उसे चेंज नहीं होना ना, 2 वोल्ट के बाद उसे चेंज होना है। ओके। तो जो तो होगा ना कि एक्यूरेसी का मतलब होता है कि जो करेक्ट वैल्यू है उसके कितने पास में आप जा रहे हो। एक्यूरेसी इज क्लोजनेस टू द करेक्ट वैल्यू। जितना करेक्ट वैल्यू के हम पास में होंगे उतनी एक्यूरेसी ज़्यादा होगी। प्रिसीजन मीन रिपीटेबिलिटी, कि जब हम किसी चीज़ को बार बार करते हैं, यदि बार बार करने से वही रिजल्ट आता है सेम, तो हम कहेंगे कि प्रिसीजन गुड है। यदि हम एक बार करने के बाद दूसरी बार करते हैं और रिजल्ट डिफरेंट आ जाता है, तो हम कहेंगे प्रिसीजन अच्छा नहीं है। तो प्रिसीजन का मतलब होता है कि दोबारा करने से यदि सेम होगा तो गुड प्रिसीजन, सेम नहीं होगा तो बैड। ओके, दैट इज द रिपीटेबिलिटी। If we are using same inputs again and again and we are getting the same output, then it is good precision. Next question is whether accuracy and precision are same or different. Like if we are having the output that is y dash, okay, and that is not the exact output. True value is y and we are having y dash. So that means the accuracy is not good because we are having the different output from the real one. Okay. But repeatability may be good in the same case, because if we repeat the experiment again and again and we are getting same y dash, we are getting y dash again and again, that means precision is good, that means repeatability. But accuracy in this case is not good because the y dash is different from y. Okay. Now it is shown here that we are having 1, 2, 3, 4, 5, 6, 7, 8 ops, and this is non-inverting terminal, all non-inverting terminal connected together, and then in turn it is connected to here, to this point, mean to the input is given here. If it is input is given here, it will go to every comparator. Okay. Now here we are giving a voltage V at this point. Okay, then we are having 1, 2, 3, 4, 5, 6, 7, 8 resistors, and here it is grounded. Grounded means 0 volt. Now at this point it will be 1 by 8 volt. At this point 2 by 8. This point 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8. These voltages at with the negative terminal, inverting terminal of the op. Here it is 0. Here with this negative it is 1 by 8. Then here 2 by 8 and so on. And these voltages are fixed and given to the inverting terminal. Okay. Now here the output of the comparator. Again, output of the comparator, different outputs. 8 op and 8 outputs. Then these outputs becomes the input of what? 8 line to 3 line priority encoder, and it in turns it will give us the output only of 3 bits, y0, y1, y2, least significant, most significant. Okay, and here it is the analog input, right? Now here it is an op as inverter, non-inverting terminal, voltage VA, inverting VP. Now if VA is greater than VP, mean at the plus voltage is greater than VP, then output will be high. If if VA is less than VP, what happens? Output will be low. If VA is less than VP, well, VP will be dominating, and if VA equals to VP, the previous state will exist. Okay. Now if this input voltage is given, this voltage will go to the every comparator. But what happened to this comparator? Here the fixed voltage is 0 volt, which is given to negative terminal, and the black line, positive terminal, it is getting greater voltage, greater than 0. So here comes the 1. But all other comparators, the voltage at the negative terminal is greater than 1 by 8 volt, equal or greater than 1 by 8 volt. So the output remains 0 for all other comparators. Okay. Now if the voltage is given between 1 by 8 and 2 by 8 volt, so what will happen to this comparator? The voltage black line, positive terminal, here it is greater than 0, so 1. At here to black line, the voltage is greater than the negative is at 1 by 8, but our voltage is 1 by 8 to 2 by 8. So here also the voltage is greater to the black line, positive terminal, so the output comes to high. Okay. Now at here, the voltage, fixed voltage is 2 by 8, but the coming voltage is between 1 by 8 and 2 by 8. So the remain 0 to all other comparators. Now similarly we can explain the same logic of all these voltages. Okay. Now the other technique of ADC, that is analog voltage. We are having analog voltage given to our device, which converts into current. So we are getting now constant current, and it is used for charging the capacitor. Okay, so capacitor getting the charge, the slope, with which the capacitor is getting the charge, that slope becomes a function of the intensity or the amount of the charging current. Okay. Now we are having a graph between time and voltage to capacitor. So this is a slope, and the slope is tangent theta. Tan theta is a function of the charging current. Okay, mean it is how much the theta is. If theta is less, mean charging current is less. This is 1, 2, 3, 3 slopes. And in case of 2, have more slope, mean more charging current. And in case of 3, less slope, mean less charging current. So let we select a particular voltage along the y-axis, V dash, and we're having the 3 different times shown, T1, T2, T3. Then we're using op to amplify the voltage. Okay, then that voltage is given to a logic circuit which converts the voltage into the times as shown by the graph. We are having 3 different times, T1, T2, T3. So one thing to be noted, if the voltage, like if the line number if the charging current is less, then there is a slope number 3, and time is t3, which is a greater time. If the charging current is more, like the case number 2, okay, and the time is less, which is t2. So what it implies that the charging current and time which we are getting, they are inversely proportional, approximately. More charging current and less of the time. Okay. So let me consider another time t which is fixed. And if the obtained time t, small t, is subtracted from the fixed time, then the things becomes other way around, that charging current comes proportional to the capital T minus small t. Now charging current becomes proportional to capital T minus small t. So we're having the device which converts the voltage into the proportional time, like t minus small t. So here analog input voltage converted into charging current converted into the time scale times t minus small t in proportion. Then we're having the AND gate. At the one input there is a high frequency clock. Okay, and to the other input there is that t minus small t, that time interval, and AND gate allows the high frequency signal to pass for particular time t minus small t, and then that high frequency given to a digital counter which counts which makes them visual counts, but it's a limitation because working depend upon the capacitor, which is a passive components. And if with easing the capacitor slope changes, then it will affect on the output. So to overcome the limitation, we are having the dual slope, double slope ADC instead of single slope, because single slope having limitation because it depends on the passive components, that's the capacitor. Output will be affected then. So to overcome the limitation, we are going to discuss the dual slope. So dual slope having the advantage is that output is independent of the passive components. And how does it will happen? This way to study. Okay, and we're going to discuss diagram now. That we are having an integrator. We are having integrator like this is an op, minus plus, and here a resistor and a capacitor. This integrator circuit using op, and here is a switch having the two inputs. There are two inputs. We can turn the switch to different inputs. The input one, which is the analog voltage, and input 2, which is some fixed negative reference voltage. So what we are giving to resistor, it depends upon the position of the switch. May be given V input and may be given minus V reference. Positive is grounded. Then what happens? When input is given positive, current flows. No current, op never draws any current. So this is virtual ground. Whole of the current passes through the capacitor. Whole of the current, comes to capacitor. The capacitor starts charging. There's a charging begins. Left side of the charger will get the, Now when the V input is applied here, the current starts. Then whole of the current, that current is flowing, and along this way. Op never draws any current because never draw any current, and moreover this point comes at the virtual ground. So capacitor left side plate attains half the virtual ground. So it implies the right side of the capacitor goes to more negative. Okay, it goes to more negative, right? So this negative voltage is increasing at the output side, and let this is happens for time t, depend upon the switching time. So now we change the position of the switch at time capital T, and then the minus V reference is connected here. So now the current direction will change because negative V reference is applied. So the current will flow along opposite in direction. Again, you know what happens? This is virtual ground. That means the right hand side of the capacitor goes to lesser and lesser negative. Mean it goes towards the positive side now. So what happened? Negative voltage at the right side of the plate will go on decreasing. So it's going slowly up. So after some time, that becomes the 0. And this slope depends upon the V reference voltage. Okay. It comes to the 0 point. Now, what happened? We are going to change the V input. V input is increased after sampling time capital T. If V input is increased, what happened? The charging current will also increase. And with the result, and the charging current will become now, with the result charging current will also increase. This results the rate with which the capacitor is charging will also increases. So this is second another slope, more slope. How are getting more slope? If the input is increased, only then. And again the sampling time is the same. It increases. Now after time t, we change the position of switch, and minus V reference is again connected to the input. As minus V reference is connected, now discharging of the capacitor starts. Now discharge will be at the same rate as was in the previous one because minus V reference is the same. So the discharging slope is parallel to the previous one. So this is parallel to previous one because there is no change in discharging. So what happened? Ultimately we are getting more time T2. So we are getting more time T2. So it implies that T plus T2 is now, it is greater than T plus T1 because the input voltage was greater. Input analog voltage was greater. So with this technique we are again converting the analog voltage to proportional time. We are transforming voltage to the proportional. We are transforming voltage to proportional time. Now this is a basic equation, you know. Q is equals to Vc, and we are differentiating both sides. dq by dt, C is constant, dv by dt. Now dq by dt, rate of change of charge. Rate of change of charge, it is a current. I is equal to C dv by dt. Okay, so this is, you know, up to time t, the position 1, up to time. Second part is the second part is when the switch is at minus V reference. Now this current I is obtained from the analog voltage V input and the resistor R. This I is obtained from the analog input voltage by Ohm's law divided by the resistor R, because other end of the resistor is grounded. It is not grounded, it is at the virtual ground. So therefore I is equals to V in over R. So we'll have now dV. This is the equation number 1. dV equals to this equation number 1. Okay. Now for the second part, when the switch is at minus V reference is connected now. The basic equations are the same. So, but dq by dt is what? I is now obtained from minus V reference. Now in magnitude, and dt is, because dt has a difference, maybe it is t1 or it is t2. So let me call it as tx. So I is equals to c dv over tx. This I in magnitude, it is from V reference over R. So substituting it there, and from again here we can find dV, because dt is here tx. We find dV. Now this dV is same as was obtained in equation number 1 previously. This equation number 2, dV, because dV is same. This dV part is the same. You know how that it is like this. For this equation, this is the dV from here to here. For this part, this is the dV. Okay, that it is this. So dV is same for the analog input part and the V reference part. Okay, so we are equating the two equations. So this dV part is the same for the two slopes. So this is equation number 2, not 1. So comparing equation number 1 and 2. Equating the two equations, CR cancels out. CR cancels out. And Tx becomes, now here capital T is constant, V reference is constant. That equation directly shows that analog input voltage is directly proportional to the Tx. So this way, with this technique, we are converting voltage to time, and this device is not directly dependent upon the passive components. Okay, thank you very much.